So a cone, much like a cylinder is like a prism with a circle for a base, a cone is basically the same as a pyramid that has a circle for a base. So it makes sense that it really has the same formula. 1/3 the area of the base times the height. So now we're going to use pi r squared for the area of the base. So here's a conical paper cup. Find the volume and then figure out how much water it holds, how many fluid ounces. So we're going to find the radius and the height of the cone. So the radius, we're told, shown right here that the diameter all the way across is 2.2. So that means the radius is 1.1. And then the height, it's labeled for us right there at the 1.8 that's right there is actually not the height because they would be filling it in the middle. So we need to find the actual height. What they're actually telling us is 1.8. Sometimes that's called the slant height. That's not what we want though. We want this. So to find out what the height is, if you look at what we know the radius, we know this slant height. We're just looking for the height. That makes a right triangle, so we're going to solve it like a right triangle. This was 1.1. You don't know that. You can call it x, you can call it h, whatever you want. And this is 1.8. So, Pythagorean theorem. 1.8 squared equals 1.1 squared plus x squared or h squared, whatever letter you want there, whatever variable. So that's 3.24 equals 1.21 plus x squared. Subtract that over, you get 2.03 equals x squared. Take the square root, and we get the height is about 1.425. That says round to the nearest hundredth, so 1.42, because it was 1.424. So now that you know the radius and the height, you can find the volume by doing the area of the base, pi r squared, times the height. But since it's a cone, it's also 1/3 or divided by 3. We use 3.14 for pi. And after dividing by 3, you get about 1.798. So we'll say we'll round it to 1.8. It doesn't tell us how far to round. And then to answer the final question, find the capacity of the cone to the nearest tenth of a fluid ounce. So if it's 1.8 cubic inches, and 1 cubic inch is about 0.554, that's our conversion factor. We're going to convert. We have cubic inches on the top, so we need cubic inches in the denominator for our conversion. And then the 0.554 fluid ounces in the top, in the numerator. So you multiply that out and you get 1.8 times 0.554 is about 1 when you round it, actually. So right after Cindy buys a frozen yogurt cone, her friend calls her, they talk on the phone for too long, and her ice cream melts. If frozen yogurt has the same volume before and after melting, and when melted it just fills the cone, how much frozen yogurt did Cindy have before she talked on the phone to Maria? To the nearest tenth of a fluid ounce. So we know the slant height again. They give us the diameter is 2.4, so that means the radius is 1.2. Just cut it in half. And we need to find the height, just like we did in the last example. So the radius is 1.2. To find that height, we need Pythagorean theorem, so we're going to do 1.2 squared plus x squared equals 3.9 squared. So take the square root of 13.77 to get your height. It's about 3.7 inches. So it says now find the volume of the cone in cubic inches. So volume of a cone is 1/3 area of the base, so pi r squared, times the height. Use 3.14 for pi. Don't forget to divide by 3. So about 5.577. And then find the capacity of the cone to the nearest fluid ounce. We're going to have to go back and get that conversion from that last problem. 1 cubic inch is 0.554 fluid ounces. So if we have 5.577 cubic inches over 1 cubic inch is 0.554 fluid ounces. So you multiply that out, you get about 3 to the nearest fluid ounce. We got 3.089, so the nearest fluid ounce would be about 3 fluid ounces. Another composite figure, just find the volume of the two figures that make it up. So we have a cone and a cylinder. So we have a cylinder with a radius of 8. The height is 19. Volume is the area of the base, pi r squared, times the height, which is 19. And then we'll do the cone. Got the same radius. But it's a cone, so it's 1/3. And then we need the height. The whole thing's 32, but it goes up to 19 here. 32 minus 19 is 13. So 13 is the height of our cone. There's 19 below the cone, so there's 13 above. So the volume of that cylinder, we get about 3,818.24. And the volume of the cone is about 870. And we are adding those together. The total volume, 4,689 point, what does it sit around to the nearest cubic millimeter. So we don't need any decimal.